Hello again, chemical systems. So this video is the instructional or demonstration video for water synthesis. This is an assignment you guys are going to do today. I encourage you guys to read these instructions carefully. At the bottom, I tell you what I'm going to be grading on. But let's just start with this chemical equation right here. This is the chemical equation for the synthesis of water. So as the reading described, a synthesis reaction is when two or more reactants, and right now I have hydrogen gas and oxygen gas, combined to form a single product. In this case is water vapor. So what's actually going on here is that there's a lot of rearranging going on here because, as I described in my first video today, each water molecule only has one oxygen atom, but I start with two oxygen atoms in the oxygen molecule. So there's a little bit of rearranging going on. I want you to take special note of a few things. These subscripts tell you how many atoms of that element are in the molecule. So for water, I have two hydrogens and one oxygen. If there's no subscript, that's an understood one. Oxygen gas, there are two oxygen atoms for each oxygen molecule. Hydrogen gas, there are two hydrogen atoms for each hydrogen molecule. But then there's some other numbers here. The 2 in front of the hydrogen gas tells me that I have two hydrogen molecules. The 2 in front of the water vapor tell me I have two water vapor molecules, or two water molecules. So what I want you to do is I want you to use a structural formula or a ball and stick model or some other method to show diagrams of each of these reactants and then the products. Instead of just showing you what those look like with water, I'm going to show you a different reaction, a different synthesis reaction. This is the synthesis of ammonia. So let me just write down here. So ammonia, I have three hydrogen molecules plus one nitrogen molecule, so it's just N2, will yield two ammonia molecules. And the formula for ammonia is NH3. Okay, so this simulation is kind of nice, and there's one just like this for water on the agenda. This simulation is kind of nice because it arranges things into, it separates all of the molecules out. So I can see here's H2, here's H2, here's H2, and here's N2. So remember, and for every hydrogen atom, you have two hydrogen, for every hydrogen molecule, you have two hydrogen atoms. And the same for nitrogen. For every nitrogen atom, you have two for every nitrogen molecule, you have two nitrogen atoms. Now, this doesn't always happen. You've seen a lot of H2, N2, O2. These are called diatomic molecules because it's made of two of the same atoms. But there are cases where you can have molecules that are numbered differently. For example, helium likes to stand by itself, and helium, you don't see He2 or whatever. Helium always stands alone. There's some atoms that do that. Also, oxygen, a different form of an oxygen molecule will be O3. That's called ozone. I just want to just kind of bring that up to show you that it's not always going to be two of the same atoms per molecule. It doesn't always work like that. But anyway, what this is going to show me, so if you do something like this, this would be kind of like part one. What I mean by structural formulas, so one way to represent this, instead of drawing these little balls, I could have H is bonded to H, H is bonded to H, H is bonded to H, and then N is actually a triple bond, but you don't have to show that. It's bonded to each, it's a triple bond to N. If you didn't know that N is a triple bond, I'm okay with you just leaving it N, and that's okay. We're just trying to show how the atoms rearrange themselves to make the final product. So now I'm just going to use the simulation to kind of show what the products look like. So remember, this formula right here tells me that I have 2 ammonia molecules. Each ammonia molecule has 1 nitrogen atom and 3 hydrogen atoms. So here I've put my big green nitrogen atom and the 3 smaller hydrogen atoms. Oops. And that's what my final products would look like. And so I've drawn structural formulas for all of my reactants. Now I can draw structural formulas for my products. And again, if you don't want to use structural formulas, if you just, I'm kind of using the simulation to show you what a ball and stick model might look like. There's really no sticks here, but there are balls. You would use sticks to show the bonds between each one, kind of like that. It would be nice if you could label which atom is which, so I know what's going on. Or color code like the simulation did. So I'm sorry about my handwriting, but that's kind of what I'm asking you. I'm not going to ask you to do ammonia because ammonia wasn't really in the reading, but this is your example of, so water is going to look similar to this, but of course the proportions are a little bit different and there's different atoms involved. But so you can either draw this diagram on paper, you can do a video, you can use Google Slides or Google Drawings. I know some of you guys like doing that. Whatever you're most comfortable with. If you have any questions, please let me know. I'd love to meet some of you guys on Zoom and talk to you, or I'll be at the Excel Center this week. And right here it tells you what I'm grading for. I want you to show me the correct molecular structures and the correct number of molecules. And I think I explained all the numbers there. So thanks for watching. I'll talk to you later.